Hi my friends, we create today a screw with the thread, conventional thread, like in this picture, and with the texture instead of coil, comparing it with a real thread created with the specific tool. We start as usual a sketch on this plane with X to the right, starting with creating a polygon. This option like this, which has a vertical side with dimension of 36. Where from? From here, 36. The screw is M24, the length is 120, and this head is 15. Remember this. Finish sketch, extrude 15. Okay, and now we use the plane diagonal. We project constructive this edge. We disable constructive, F7, Foxtrot 7 to see inside, and we draw a triangle here in order to make the chamfer good. I hope everything is okay. Good. The angle from here is 60, and now we remember that we have here D0 is 36, D0, remember, so we project as center line the Y axis, disable center line, because we put here the diameter D0, which is 36. You can activate expression to see that D4, the actual symbol, is equal to D0. Good. Now we apply revolve. We choose this axis, one profile, one axis, nothing to choose, nothing to select. We change here from join to cut, and we have the chamfer. Okay. The next step is to use the plane XY to draw a rectangle starting from the origin, tab 120, tab home. Where from is this 120? Is from here. Okay. Why I didn't put the other dimension? Because this is a diameter and I need to have an axis. diameter is 24. Good. Home, revolve, OK. Now we have to create a fillet here. The dimension is 0.8. Here, fillet 0.8. OK. And a chamfer of 2. 2 is the default value. OK. F6, Foxtrot 6, and we have this. Now, to apply thread, we use the tool thread. The tool thread, I am very careful to select this end and not this end, because if I choose the up, you see the fillet starts from up, and I want to start from bottom. Cancel. Once again, thread from down, and the fillet is upstairs, up side. The value is 56, but where from? From here and not from here. You see, this is a great difference for us. A difference of 2 millimeters. So we put here 56 minus 2, minus 2. Okay, good. I can change minus 2 with the dimension of chamfer. Where do I find this? I find this at the chamfer here, D12. Let's do it. Thread, double click, not 2, G, D12. When you change the chamfer down, here will be reflected the modification. Okay, but I see that this is not a right hand thread, because I didn't check this option. Okay, now is to the right. F6. We have here our new screw, steel, but semi-polished to be nice. What are the data? iProperties, physical, update, and I copy this volume, the volume, copy, close, and I put here that value in a notepad text file. And now let's create the other kind of thread, the real kind. We just delete this texture and we put the other, but this needs to create a profile here. Let's see how we need to create a profile in the plane XY. I have to project the y-axis as a center line. Home, F7, and I see this inside, and now I'll project construction, this generator. I disable construction and create a profile here, starting with this projection, 1, 2, 3, and a closing line with the angle, standard angle of 60, and to be symmetrical I choose easy way, making equal these two lines. Is the simplest way to create a symmetry around an axis here. Instead symmetry, I create another line, the pitch line, not in the middle, but somewhere here, vertical, or parallel with this, and now I make them constructive, because I will dimensions to these two lines by using these diameters. This you see, when we made the thread conventional thread, we didn't know what is the pitch. The pitch for M24, the normal pitch, is 3 millimeters. This was chosen as default. M24 without any specification after or suffix after is normal, and the normal is 3 millimeters. What we have here, the pitch, this 3 millimeters, the major diameter, the minor diameter, the red is the thread, the green is the nut. We now are concentrated on the red, and the profile for the red is so a small arc here and the right side. There is another diameter here, pitch diameter. You see on this D2 we measure the pitch. The pitch is from here to here, and half the pitch is measured on this diameter. We need this to create the hollow here. Good. What are dimensions? 22051. I read here 22051 and 20.752. 20.752. This is a picture. I cannot copy this, but from here I can copy. This is why. Good. The pitch diameter is 22. I'll copy it. Copy, Control C, and this is the pitch diameter. Paste. I don't want to forget the pitch, which is 3 divided by 2, because this is half the pitch. Okay, and now I copy the interior diameter. Why? To place another dimension here. Interior is 20. Good. Now we have the profile. How many dimensions are needed? 1 dimension needed. The distance from here to the bottom. But before we create that arc, starting from here, ending here, and moving to become tangent. Of course, tangent up and down. Good. Escape to change visibility, and now we put here another dimension from the center of this arc, which is on the axis, symmetry axis, and to here is just 56 home. F6 beta. Now to create the coil here, the helicoil, we use the tool coil. When start to use this tool, we see here just already selected the profile, and we have to choose the axis, which is this one. If we look frontal, or better so, we see that the coil is oriented up, not down. We change this from here, and now we choose to cut the body. Coil size is with pitch 3, and say 15 revolutions, not enough. 20 enough. You see, they are outside the body. Okay, that's all. See, the coil is really made on this screw. Now we have to finish this, because no tool can do it, only 3D printing, which can do anything. We create a sketch, we finish the sketch. Extrude, not with adding material, but with subtracting material all the way. Okay, F6, and now let's see what is the eye properties. Update, copy, and paste. You see, if we remove that dimension, we have here a difference between the mass of the screw with texture against or versus this one, which has subtracted material from it. Good. Another difference when we try to make a comparison is the size of the file. I have here that too with texture and with coil. What is the difference between them? This is 120 kilobytes dimension of the file on disk, and the other is 520. 120 versus 520 is a great difference. The bonus this time is to use the content center to open a similar screw or identical screw and save it for yourself to use in your project. Here is how to do. File, open from Content Center the great library of Inventor. This was already opened by me, but I'll show you how to do. You have here cable and harness, fasteners, interesting for us now, mold, other parts, shaft parts, sheet metal, structural shapes, and tight tube and pipe. We concentrate on fasteners now, and we look to bolts, not countersunk, not hex head flanged, but regular screws. We look for ISO 4016 is contains just the modeled screw M24 with length 102 and 20. We open it. If we try to change anything, for instance to choose the aspect semi-polished, we cannot do this because we cannot change something from library. You can save the part from Content Center using Save As and choosing your workspace, where you can put under this name a new part. This part is yours and you can change it anything from this part. This is the result. It seems to be like ours, but if you open the parameters tab, you can see a lot of details here. Just look to them. You see there are some definitions. 24 is N and D, 120 is NLG, and they are used in the regular parameters. You know something about this from our previous tutorials, and now I wish you good luck, and please be careful to subscribe. Just click the subscription in YouTube for me to see how many of you are interested in my adventure with tutorials. I want to make a lot of tutorials, but only if I have audience. If I have no audience, this is not useful at all. Bye bye.